Okay, little brain freeze there. I had it right. Okay. I just didn't like what I saw because I was thinking it would be something else, but just thinking it through, the units are correct, everything's correct, and it is I omega, where the omega is the omega you would have at this velocity at this distance. Okay? So, yeah, I said it right all the way through, and then I didn't believe it. But again, you always want to stop and check yourself. So I don't mind doing that once in a while. So there it is, that reconciles it. Well, the big point is that you don't have to figure out this R. The big point is that you get the same thing if you use this R. Okay? Because in this case, your theta is going to be, your theta is not going to be 90 degrees anymore. So what it is, and it's very simple. Pondering, I'm going to let you ponder for a second. This takes some pondering. Okay? Okay. The reason this gives the same result is everything here is the same except theta is not 90 degrees anymore. Theta is now this angle, 30. Okay? So now, well, let's put it in green because we're in our green phase now. Okay? It comes out very easily. I'll say theta is no longer necessarily 90 degrees. It could be 90 degrees because this is going to apply at any point. Okay? Wherever the particle is, you're going to have a theta, and the theta is going to decrease as the particle gets closer and closer to this line. Okay? So theta is no longer necessarily 90 degrees. Magnitude of L is still magnitude of R times the magnitude of MV times sine theta. Okay? Now before I go on, I'm going to give this R a special notation and not just its own color. Okay? I'm going to call this R min, the minimum possible, the R of minimum possible magnitude. Okay? So I'm going to have to put a min here, 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 and here. And here. I still missed one. So if you see one, let me know. Okay. Well, this magnitude, this magnitude, this magnitude, right? That equals magnitude of MV times the magnitude of this R times the sine theta. But you see, I've got a right triangle here. You're pondering as you write, so I'm waiting. That's fine. Okay? Okay? You got a right triangle here. What do you do if you get the hypotenuse times the sine of theta?
I'm not sure.
We get the side opposite theta. And if you can't look at a right triangle and immediately see that, review some trigonometry. Right angle trigonometry is very simple and concise, okay? You probably haven't used it enough, and probably haven't used it enough in this course, even though there have been problems, okay? You gotta see that second nature. You gotta see that this is our cosine theta, this is our sine theta. You don't have to think about some mnemonic. Oscar had a handful of apples or whatever it is.
Those
Okay.
are not helpful.
Huh?
Those are not helpful.
Oh, yeah, they are when you're first learning it, but if you rely on them after you've been using it, you haven't done enough problems. And again, people are not assigned enough problems in these courses. You can't escape it if you've been assigned enough problems. And if you get in the habit of not learning short term. Okay? And that's a habit you gotta develop because the educational system rewards short term learning. It hasn't gotten to the point. And in many courses, it's different. But, okay, so anyhow, get off my soapbox. So the point is, and this should be completely obvious at this point, that this magnitude of r sine theta is just this. So this equals the magnitude of mv times r min, which is just not going to go through the details of that. I should be better educated. Okay. You get from here to here to here. This is going to give you exactly the same thing this does. Okay? And it's simply because of this, which is something that should be visually and geometrically obvious. So work toward that. Okay? And this tells you then that no matter where the particle is, you take the mv vector and the r vector to that point and you have its angular momentum. Okay? And that's a big deal. So you really want to nail this idea and this picture.